Hey everybody, this is Paul. So in this tutorial I'm going to do an introduction to hash tables. So a hash table is a data structure that is used to store information. So the information in the hash table basically has two main components. So it's going to have some sort of key, and then it's going to have some sort of value or some sort of record. And so basically a key could be something like, for instance, my name, and the value could be something like my phone number. So we could basically create a hash table to store a bunch of people's phone numbers. And so what happens is the hash table, it's a way that we can implement an associative array. And so we're basically going to map this key to this value here. And at the heart of a hash table, we're basically just going to have this array structure. And so this has got a bunch of different array elements here. And we've got index 0, 1, 2, 3, and 4. And if we were to really create a real hash table, if we were going to actually implement this in code, we're going to make our hash table be much bigger than this, but this is just kind of for illustrative purposes, so this information can fit on the whiteboard here. But in reality, we would normally make hash tables much larger than this. So anyway, the way this works is we're basically going to write a hash function. And so what the hash function is going to do is it's going to look at a certain key, and then it's going to evaluate that key, and it's going to spit out some sort of index number, and it's going to tell us what location in the array to store this information. So for example, we'll just go ahead and just write this out. So our hash function is going to take a key value, and as a result, it's going to give us an index number. So for example, we could do hash, and then as the argument we could enter my name. My name could be the key. And then we could just say that our hash function evaluated this key, and it said, okay, that should go in index 3. And the way the hash function is written is that every time you enter that key, if it's the same key, it's going to spit out the same index number. So every time I enter Paul into my hash function, I should get the index number of 3. So we could just represent Paul as a circle. So we'll just go ahead and put that here. So this circle is going to represent my name and my phone number and where it is located in the hash table. So let's say that we wanted to add some other person. So what we would do is we would just put whatever that person's name is as the key. So it's going to evaluate person, and we'll just say that it spits out an index value of 1. So person can be square, I guess. So this square will represent some other person's name and phone number. And according to our hash function, we're supposed to place that in index 1. So we could keep on going, and maybe we'd find another person's hash value goes in index 2, and maybe another one goes, they can be a diamond, I guess, that will represent another person's name and phone number, and we find that they go in index 4. But what happens if we're wanting to add another person, and we'll just put somebody, I don't know. So we're adding somebody else's number, and what if we find out that their hash value ends up being 3? Well, we go and we look and we go, uh-oh, there's already a name and phone number stored in index 3. So there's a lot of different ways to go about this to avoid a collision. And the way I'm going to implement this when I code this in my videos in the next few tutorials is I'm basically just going to create a link and create basically just a linked list off of each one of these indexes here. And so I don't know what shape we could use here. We could just do squiggly line or something like that. So what I would do here is I would just put squiggly lines name and phone number inside of this element here. So basically this is called chaining. So if we needed to add more, let's say we got another one in index 3, we would just link that off of squiggly lines name and phone number. And we could do sideways squiggly line. That can represent that person's name that person's name and phone number. And anyway, I think you guys get the point. So all these shapes just represent somebody else's name and phone number. And if we end up with a collision, then we basically are just going to link it off of that same element. So each one of these people's names and phone numbers, they basically got index 3. And so the cool thing about this is if we get a whole bunch of names and phone numbers in here, and then all of a sudden one day we want to go and look and we want to say, okay, where is somebody's, say you have the name of a person and you want to know what their phone number is, you basically just enter their key inside the hash function. And so if there was like a gajillion different names and phone numbers, you could just do hash of, whoever that person was. So that person. And the hash function is going to basically spit out an index, and it's going to tell you exactly where that person is located. And so it might be that that person, let's say we just got a whole bunch down here. It might be that that person gets a hash value of 2. So then what we do, or sorry, I meant to say 1. So whatever person we're looking for might have a hash value of 1, and then we know, even if this was like 1,000,000 index units long, we know that we don't have to look in 0, 2, 3, 4, or all the way up to 1,000,000. We don't even have to look at those. Our hash function tells us exactly which one to start at, and so then we would basically just start at this one. And if we had some chaining, we could kind of go down the list and figure out exactly, we could search through this list and figure out exactly where that person's information was located, and then grab that information out of the list that's attached to index 1. And if you do this right, you shouldn't have very many links basically off of one single index. But if you have a collision, then we're going to implement this ability to basically add a linked list to each array index to take care of any collisions. And this is called chaining. And like I said, there's other ways to take care of collisions, but this is the way I'm going to implement taking care of collisions in the code that I write. So anyway, I hope that was helpful to you guys, and now you understand the basics of hash tables and how they work. Let me know what you guys think about this in the comments. I appreciate everybody watching. You guys have an excellent day. Stay tuned for more coding examples of this. I'm going to go ahead and code a hash table in C++ on the computer screen, so stay tuned for that. Anyway, let me know what you guys think about this in the comments. Have an excellent day, and if you haven't already, don't forget to subscribe.